guys, so we've done translation, and next bit is reflection. Okay? Now, when we talk about reflection, there's, you know, this is a reflection. This is actually not x-axis. This should be y. Okay? So that's a reflection over the y-axis. You understand when I say reflection? You understand what I mean? It's, imagine this is a paper, and you've got a fold here, and you're just folding it. So you take that green triangle, and it becomes the blue triangle. You happy with that? Okay, so it's like this. You just flip it to the other side. Okay. Now, by the way, I'll tell you where a very important page is. Have a look at page 151. I'm just going to pause there. But just have a look at page 151. All the types of transformations are there. So I'll just pause here. So what I was trying to get you from this is when you look at page 151, you will see more than 10 matrices that are used for transformation. You're not going to get given most of these. You're going to get 2 of them. I'll show you which one later. The rest you're not going to get given. But you don't need to remember it, because there's a way of making up these transformation matrices. The first one you saw, the translation, is dead easy. You just put what you write in the x, you're going to put what you're going to do to the y. That was easy. Okay? Now we're going to try and figure out what is the transformation matrix that is a reflection on the y-axis. But it's important for me to understand what does it mean physically, reflection over the y-axis. Okay? Right. How do you do it? How do you find out? It's going to be a matrix. It's going to be some kind of matrix, a 2x2 matrix. We're only working with 2x2 matrices here. Okay. There's the fogger guy. Just a second. Okay, so how are we going to do it? The secret to do that, we're going to use what we call the unit vectors. Okay? Remember vectors, I used the word. The vector is basically a matrix with just a column or one row. Okay? And unit means that it's 1. Okay? So the unit vectors, there's 2 of them. Okay? There's 1, 0. Okay, I won't do the comma. 1, 0. And this one is 0, 1. Okay? So we've got these 2 vectors. Okay? In fact, I should really classify a little bit. We use them as a column. So this is going to be 1, 0. That means the x is 1, the y is 0. And this one is 0, 1. So yeah, sorry, we're using them as a column. Does that make sense? Okay, the x, the y, the x, the y. And what we're going to do is transform in our mind each one of these vectors. Okay? So when we reflect, this vector, what will happen to him? He will go like this. Can you see it? Okay? So what will he become? I'll draw it in blue. Negative 1, 0. In other words, I'll write it down like this. 1, 0. Vector 1, 0 is transformed into negative 1, 0. Okay? What happens to 0, 1? Okay? 0, 1. What did you say, Toby?
0, negative 1. Over the x-axis.
Does he flip down? Think about it. Think about it. This is reflection over the y-axis. All you do is do like that.
It's only over the y-axis.
It stays the same. Okay? It stays exactly the same. Okay? So 0, 1. Now I've written the green one, the original one in green, the new one in blue. Because we're going to use those blue ones now to write the matrix. And I also, if you can see, I wrote it staggered. So I start with the x-axis, the one which is based on the x-axis, and then I move to the one on the y, and I staggered them. And the reason is, all I got to do now is take that column, write it like this, take that one above, and voila. Okay? And just check, if I check, you can check with me on page 151, reflection over the y-axis, there's got -1, 0, 0, 1. So we got it right. Okay? Right? Okay, so it's very important to find out the unit vectors, find out what were they transformed into. Okay? Write them. I mean, you don't have to do it staggered. It's just a way of remembering that you just put your x first and the y, and then we got it. Okay? Now, before we move on to the reflection of the x-axis, I just want to show you, and I'll just do it once now. Okay? What will happen, for example, to a point, let's say to this point. This point is, let's say, 1, 0, 0.5. Okay? Now, what do you reckon it should become once we reflected it? What should it become? 1. What is the x going to be now? Minus. So it's going to be minus 1, and the y, 0.5. The y shouldn't change. Okay? This is what we did just by thinking or by looking at the diagram. Let's see if it works. So I'm going to multiply. Okay, I didn't really talk about that. So we can now, I should have done that. We can reflect coordinate and shapes by multiplying the coordinates by this transformation matrix. So if we take this coordinate, what is this coordinate? It's a column vector, 1, 0.5. 0.5, okay? If we multiply this matrix, we should, in theory, get that. Let's see if it works, okay? How do I multiply? Remember, bam, bam. Minus 1 times 1, which is minus 1, plus 0 times 0.5, which is 0, minus 1. Bam, bam. 0 times 1 plus 1 times 0.5, we get 0.5. We got it. Okay, can you see it? Right? We could have done it, I mean, I'm not going to do it now, but you can do it, for example, let's say this is 1 and 1. It's the coordinate 1, 1. That should obviously be minus 1 and 1. You can try multiply this matrix by 1, 1, 1. You'll still get minus 1. Okay? I'll just pause here for a second. Right, so our next type of reflection is the reflection over the x-axis. So imagine if we had fold down the x-axis and we're just folding it down like this. Okay? Or folding up. You know, if it was up, it would move down, and if it was down, it would move up. Okay, that's reflection. Okay? They swap places. So just to make sure you understand what I'm saying, if let's say I had the point 2, 2, that's the coordinate. What will be the new coordinate and the reflection in the x-axis? 2 minus 2. Okay, the x remains the same, now it's the y that changes. Okay, and again the question is, what is my multiplication matrix? If I multiply, let's say I've got 2, 2. This is this coordinate. I want to multiply it by something, so I will get 2 minus 2. And I want to know what this thing is, right? What do I do? What's the secret? The unit vectors, right? I draw the unit vectors. 2 unit vectors. First one is the x, which is 1, 1, 0. Okay? The x is 1. We call it unit because x is 1, and 1, the y is 0. This one is 0, 1. Sorry? So, important point to explain. Okay? The unit vectors are always the same. It doesn't matter if we're looking at triangle, circle, if the points are 2 or whatever. It's the unit vector is 1, 0, and 0 and 1. Okay? So what we're going to do is we're going to ask ourselves, how are they transformed? So we always start with the x, with the x one. Okay? So 1, 0. Under the reflection in the x-axis, okay, what will happen to it? What will it become when I'm reflecting over the x-axis? 1, 0 will become. I'm folding, I'm flipping everything through the x-axis. What will happen to 1, 0? Stay the same. You're absolutely right. Okay? Before it was the y, the 0, 1 that stayed the same. Now it's the 1, 0 that stays the same. Okay? And then if I'm looking at the other vector, 0, 1, that will become 0 minus 1. Okay? Because that is going to be flipped down. Okay? And you see, I start with the x, then I move the y. I did a little staggeration going on here. Okay? What will be the unit? What will be the matrix? Remember?
1, 0.
Let's check page 151. Reflection in the x-axis, 1, 0, 0, minus 1. So you don't need to remember that.
It's the opposite from the
It's
y.
the opposite is minus 1 time. You're right. You're right. And we're gonna can look at these connections later. Okay? I'm just to finish up here, and I think this will be it for today. I'm just gonna multiply it. And I'm gonna see. In theory, what we need to do is, if I multiply this reflection in the x-axis by this column vector, I should get 2 minus 2. Okay, let's see if we get that. Okay? 1, boom, boom. 1 times 2 plus 0 times 2 is 2. Pump, pump. 0 times 2 minus 1 times 2 is minus 2. Yes, we got it. Okay? Alright? Maybe just to finish up here, this is obviously a trick. I just showed you a trick. How, if anyone is interested why that actually works, then we can chat about it later, but we're not going to do it in the video, okay? But this is a very good trick to help you figure out what is the rotation matrix, because the question that you can get in a test is, let's say you have a point of 4, 3, okay? And you asked, write down what is the reflection in the y-axis matrix, and then find out the coordinate, the new coordinate other than the reflection. So there's quite a lot of stuff going on, and nobody's expected to remember these things. In fact, if you try to remember them, you're probably going to get it wrong. We'll just work on this method, and this method will help us. If you're still looking at page 151, I'll show it to you here on the camera. You've got all the list here of these matrices, and you need to know all of them. Okay? So this method is the best way to remember. I'll stop here. We're not finished with reflection. We're going to have to finish it next week. Okay?